All right, so on the top of the next page, what we're talking about here is everything that we have referred to, except we're going to deal with some graphs, okay, and what they're asking for. So first of all, it says let S of t be the given function, and the biggest piece right here that we need to make sure of is that we understand what this means. What is this saying where t is greater than or equal to 0? What is t representing? Time. So what is this saying?
After 0.
It could be equal to 0, so at time 0 or above. So all non-negative values, right? All non-negative values. Okay? And they give us that the position is in meters and the time is in seconds. So for a problem like this, if we have to label our answer, bless you, you need to make sure you label your answer. So in the first part, we want to find the velocity, speed, and acceleration functions. So we're not evaluating anything, right? We're just finding what those functions are. And then in part B, we want to find the velocity, speed, and acceleration at a given time, 1 second. And then we'll graph all of those. Okay? So in part A, we're given the position function. So S of t is equal to 2t squared minus 8t. All right, so we want to find the velocity. Find the velocity. Velocity is what? The derivative of the position. So this is going to be what? 4t minus 8. Okay, done. There's the velocity. What about speed? Just the absolute value of this. So this is the absolute value of v of t, which is equal to the absolute value of 4t minus 8. Okay, 2 for 1. And then the last one would be acceleration. So a of t. Yeah, so that's just what, 4? Okay. So we have our 4. We have our position. We have velocity. We have our speed. And we have acceleration. So they're all right there for us. So in part B, it says find the velocity, speed, and acceleration at time 1. So let's see. We've got v evaluated at 1. So this is 4 times 1 minus 8. So what would that be? Negative 4 meters per second. What is this telling me? Yes. This gives me the direction. Okay. And the magnitude. Questions? So then if we want to evaluate the speed, it is the absolute value of our velocity at 1, which is basically evaluated here. I just take the absolute value. So it's 4 meters per second. Agree? Okay. Then we want to evaluate the acceleration at 1. It's just 4 what? Meters per second squared. Okay, so that's the good thing when you just have a constant there, right? You don't have to plug anything in. There's no place to plug it in. Okay, is everything evaluated? Did we get everything we asked for? Okay. In this last one, thank you so much. In part C, we're going to be sketching these graphs. So they're not going to be perfect. I'm not asking you to find all the points, but there are some concepts that I need to make sure that you are clear on. So in part C, we want to graph the position function. So S of t is equal to 2t squared minus 8t. First of all, what would that be a graph of? Yeah, it is a parabola, and we could go through and find the vertex, okay, but I'm just going to let you know that it's below the x-axis. But one of the biggest things that you need to make sure of is when you sketch the graph, typically when you would sketch a graph, you would just kind of sketch a parabola like this, right? What's the problem with me going over here? Time is not negative, so really the only thing I can do is just sketch it, I don't know, like this. Right? Because it's t is greater than or equal to 0. For those of us that forget, if you really needed to find the points, you could find the x-coordinate of the vertex by using the opposite of b over 2a. Plug that value in. Everybody's just looking at me with this blank stare. Okay, that's algebra 2. That's how you do it old school without a calculator back in the day when we chiseled rocks, okay? All right. Questions? This is just a sketch, though. But the biggest thing I wanted to point out here is we can't go beyond the y-axis because time is not negative, true? At least not in this continuum right here. True that. All right, so then let's take a look, at the velocity function. So v of t is equal to 4t minus 8. So what is this? Oh, it's a line. Okay, and I have an intercept at negative 8. Yikes. So let's go like this. Now, what's the biggest thing I need to make sure of when I'm sketching this line? Again, it's got, better be straight. It's a line. But what do I need to make sure when I graph? Doesn't a line go like this? So I have to, when I use my intercept, so 1, 2, 3, 4, 5, 6, 7, 8, just a sketch. Right here is basically, it's going to look like a ray. True? Because it's going to go, not Ray the person, but a ray. Okay. And then I have an x-intercept here at positive 2, so I'll just sketch it like this. How's that? I'll introduce you. This is Ray. Okay? All right. Let's see. Let's talk about the speed. Absolute value. What does an absolute value graph look like? It's a V-shaped graph. So really, if I take this graph right here, what we're saying is my y values cannot be negative, true? So this is how we get the V-shaped graph, because what's going to happen is this is my vertex of that V-shaped graph, right? This line is basically going to be flipped up this way. Does everybody see what I'm talking about? That's where you get your V-shape, because it's the absolute value of all of these. Okay, so remember, I cannot go beyond the y-axis because time must be greater than or equal to 0, so I'm going to sketch, but I know that my vertex is my x-intercept. So I'll sketch it, I don't know, like this. This is just a sketch. This is 1, 2. So we know this portion goes off in this direction, correct? Like this. This portion right here has to flip up above the x-axis, and I cannot go beyond, so let me extend this just a little bit here. So I would say something like this. So this one is going to keep going. This one has to stop here because time can't be negative. So essentially, just this portion right here was flipped above the x-axis. Now, if we had to find it, what do? We pick and plot points. Again, we go old school, rock chisel. And then the last one is acceleration. Yeah, it's just a line, but more specifically, please don't say a straight line, because that's what lines usually are, but yes. I heard it. Go ahead. Yes, at y equals 4, but it can't go to the left, true? So if we were estimating, I don't know, 1, 2, 3, 4, it would go something like this. I've never done a problem like that, but I'm not saying that you can't. That would be a good way or use of a negative time, but we don't typically ask you. So what happens is, let's say you're looking for a value of time, and let's say you have to factor because it's a quadratic, right? And you get t plus 2 and t minus 3. So you get values where time is equal to negative 2 and time is equal to positive 3. What do you do with the negative 2? You pitch it. Because a lot of times in the problem it's going to say where t is greater than or equal to 0. That's why it's really important. So if you want to use a highlighter like on a test or a quiz or on anything that you're doing, highlight those things. So that this right here would be something that I would highlight just to remind me. Okay, remember, it's got to be greater. Because it might say, what if it said t being greater than or equal to 5, meaning we don't care about what happened between time 0 and 4.99999, right? So that's why they don't typically ask that, but that's just an example. Okay, so with respect to speeding up and slowing down, what we're looking at here is if a particle is speeding up or slowing down, you need to look at two things. What we're looking at is if we have a particle that is moving in a positive direction, a particle is considered to be speeding up if the speed is increasing and considered to be slowing down if the speed is decreasing. Well, that kind of sounds intuitive, right? But how do you determine that if you're given a function? So that's what I'm going to show you here. So first of all, we are given our velocity function. And we know that speed cannot be negative, true? Okay, so right now, velocity is negative to positive and then negative. So what we need to do is also have our speed function on here. So speed is the absolute value of velocity. So what do you think is going to happen to this portion of the graph if I take the absolute? Yeah, it flips up. So basically what I would need to do is do my best to replicate this graph up here and bring it back down to B. Okay, like this. And then the same for this portion right here. So what I'm going to do is I'm going to highlight in orange my velocity function. This is velocity. Okay, this is velocity right here. And then what I have here in my so wonderful dotted line in green, okay, and then it has to go over because this is also going to be our speed, is right here. So this is my speed function, which is the absolute value of velocity. Okay? Right there. Okay. So here's what we want to look at. Using this graph, Jay, thank you. It's hard not to laugh. Thank you, sir. So what we want to look at are these intervals. And we're going to look at the interval from 0 to A to B, B to C, C to D, D to E, and E to F. Okay, so we're looking at these graphs. And when we're looking at the velocity, what we're looking at is the location of our V of t graph, which I put in, what, orange? Okay, with respect to the x-axis. So when we're looking at, because remember, velocity is the derivative, right? So remember when we were talking about if our function is positive or negative, we were looking at the location above or below the x-axis. So from 0 to A, where is your orange portion of the graph?
Negative.
Exactly, below, so that means velocity is negative. Okay, what about A to B? Negative. Okay, remember you're only looking at the orange. B to C? Positive. C to D? D to E? And then E to F? Okay, everybody good? All right, so now when we're talking about acceleration, what is the relationship of the acceleration graph to the velocity? Okay, slope, or it's the derivative, right? So what we're looking at is the slope of our V of t graph. True or false? Okay? So we're looking at the slope. So this we're still looking at the orange graph, true? Okay. So from 0 to A, what's the slope? Negative. What's the slope from A to B? Positive. Okay, and then B to C is still C to D, D to E, and then E to F. Okay. So in terms of what we were looking at here, does everybody understand what's happening, what we were looking at? It's important that you write. So we're still looking at the slope of the orange graph, not the green. Now, to determine if our particle is speeding up or slowing down, what you are going to do is compare the signs of velocity and acceleration. So we are going to compare the signs of velocity and acceleration. If you have plus plus or minus minus, then the particle is speeding up. If you have plus minus or minus plus, what do you think is happening? Well, if the same, slowing down. Because basically they're fighting against each other. Does that make sense? Okay, so take a look here. Velocity and acceleration are both negative, so are we positive or negative here? Right, you're speeding up. What about here?
Negative.
That's right. Here?
Positive.
Check.
Negative.
Check.
Positive.
Check.
Negative.
Oh my. Okay, does everyone understand what just happened?
Yeah.
Okay, but that's the quickest way to do it, because sometimes we contradict ourselves looking at the graph. So we're actually going to be able to do this algebraically, but my biggest thing here is, do you know what you're looking for when you're looking at the velocity, given a graph? And then when you're looking for acceleration, do you know what you're looking for? If not, you need to make sure you write it on the graph, on the table.